presentation. But that kind of highlights one of the things that we are having to deal with now in terms of Java, which is a much faster release cycle. So now we have releases which are coming out every 6 months. Now, if we look at JDK 9, that came out in September of 2017. So I have to think back about that. But yes, it was September of 2017. And this was actually quite a significant release for Java in a number of ways. The first reason it was a significant release is that Oracle decided that this was going to be the last major Java release. And what they mean by major release is one that had multiple years of development behind it. And so if we look at the slide here, I borrowed the slide from Oracle. I used to work for them, so I figured they still owe me a few slides. And it lists all of the features that are on there. And there's about, I think, 86 that made it into the list there. Some of them are quite big, some of them are quite small, but there's a lot of features that went into that particular release. But there were a number of other reasons why JDK 9 was a significant release. One of them was the fact that, as I said, we switched from having a release which could be anything from, well, a bit over 2 years to almost 4.5 years, which was the longest period between releases, to a very regular release cadence of every 6 months. So the fact that I'm going to talk about JDK 12 today, only a little bit over 18 months since the release of JDK 9, shows that that is actually working. Now, the other thing that we need to talk about is compatibility. And that's really one of the reasons why I put this whole presentation together, is because the way that we address compatibility in terms of Java, again, has changed. And it changed from JDK 9. In the past, compatibility has always been a very big concern of Sun Microsystems when they first started developing Java, and then Oracle when they took over, when they acquired Sun. And so it's always been very important that you can take an application that was written in, let's say, JDK 1.2, compiled with JDK 1.2, and then you can just take it and you can run it on JDK 8 without having to make any changes. And if we look at the history of Java, that's worked pretty well. I know I've actually taken some code that was compiled with JDK 1.1 and run it on JDK 8. There are a couple of places where we bumped into some minor issues. So if you look at JDK 1.4, for example, the introduction of assertions. That introduced the idea of a reserved word called assert. So you couldn't call your variable name assert anymore. In JDK 5, we got the introduction of enumerations, and that meant that you couldn't use enum as a variable name anymore. But these were fairly minor things. I mean, if you had code that used either of those variable names, then it was straightforward. You could just do a global search and replace, and you could change your code and then recompile it. There wasn't a lot of work that needed to be done. The other thing is that if you go back in the history of Java, all the way to JDK 1.1, we had the introduction of deprecation. Deprecation was a very nice idea because what it said was that as we evolve the platform, both from the point of view of the language features and from the point of view of the APIs, we need to make changes which are not just going to be adding new things. The idea is that at some point we may want to remove features as well because either the APIs refer to things which are so old that nobody uses them, or we found a better way of doing those particular things. So deprecation came along in JDK 1.1, and we started to see API elements being deprecated. The interesting thing is, though, that if you look at JDK 8, I did a bit of research on this, and there are actually 492 API elements in the standard class library, so that's classes, interfaces, methods, variables, and so on. 492 of those have been deprecated by the time we released JDK 8. Not a single one of them had ever been removed. So that kind of defeated the object of having deprecation. If you're not going to remove anything, why do you bother having deprecation? But it was always the idea at some point we would get around to removing some of these things. And again, the key thing with deprecation is that Sun and Oracle have been quite clear about this, which is that deprecation means that you will get at least one release warning of something being deprecated and then being removed completely, which is kind of good, because if you had less than one release warning, you'd have no warning at all. So at least one release warning. The important thing about that is it means that now, with the new release cadence, we can literally see a feature deprecated and removed in the space of 6 months. Because let's say JDK 14 deprecates it, it could be removed in JDK 15. So the big thing with JDK 9 was it started a process which really has been long overdue in Java. Java is now 24 years old. And as I say, we've been through the idea of adding lots and lots of new features to the platform, but we've never actually removed things. And so it really was time to start a bit of a cleanup and looking at all the things that were in Java and what things did it make sense to remove. And this is very logical from the point of view of Oracle, because they built up a lot of technical debt. There are a lot of features that literally nobody uses anymore, and they're still having to maintain them. They're still having to look at them from a perspective of, are there security issues associated with these features? Do we need to maintain those features? Do we need to do work on those features? And if nobody's using them, why are they doing that work? This started in JDK 9 and has continued with JDK 10, 11, 12, and will continue in the future as well. And that's really a lot of what I'm going to talk about in the rest of the presentation. Mark Reinhold, who is the chief architect of the Open JDK, he gave us some advice when it came to migrating applications from JDK 8 to newer versions. And he said, if your code only uses standard Java SE APIs, then it will most likely work without change. Now, clearly that's not quite as reassuring as we would like. We'd like to see it will work without change. But because of the fact that we now are removing things as well as adding things, it's most likely. And as I say, we'll look at all the different things that might affect your application as we go through. Okay, so the first thing we need to look at is the module system. Now, I know that came out in JDK 9, and so it's been around for a while. Lots of people have done presentations on this. But if you're going to migrate from JDK 8 to, let's say, JDK 11, because that's a long-term support release, or anything newer, then you are going to have to face the fact that you've got to adapt to the module system. So I won't spend too long on this, but it's worth spending just a few minutes talking about some of the things that you need to be aware of when it comes to migrating an application to the module system. First thing is, what is it and why do we need it? Well, really, the Java Platform Module System, JPMS as we sometimes refer to it, is really two things. The first of those things is the idea of taking the core libraries and breaking them up into a number of pieces to make them more manageable. If you go back to JDK 1.0, then you'll find there are 211 public classes available for use in your applications. Move forward to JDK 8, and rt.jar has a little bit over 4,500 classes available for use. That's a good thing for us as developers, because we don't have to write our own semaphore class, we don't have to write our own array list class, they're all there for us. But clearly, having 4,500 classes in a monolithic jar file is not very practical for making reduced-sized Java runtimes. And so the idea of the module system, the primary idea of the module system, is to allow you to select only the modules you need, which contain the functionality that you need for your application. So if you look at the actual design of the module system, they broke up rt.jar into 75 OpenJDK modules. And of those, 24 are for the core Java platform, so Java SE specification. There are two what are called aggregator modules. And these are modules that don't contain packages, but only contain references to other modules. There's one which is a little bit weird. There's the smart card module that somehow ended up in Java SE and is still sort of there, and it's still part of the core platform. And then there are 48 which are JDK specific. They refer to basically any parts of the JDK that are not part of the core platform. And that could be things like Nashorn, it could be things like unsupported libraries, stuff like that. If you look at the Oracle JDK, at least up until JDK 11, there are another 14 additional JDK modules. There are 8 for JavaFX and 2 Oracle-specific ones. The other side of modularity, which is the thing that's a bit more contentious, it's the thing that requires a bit more thought for migrating applications, was the goal of encapsulating internal APIs. So RT.jar has 4,500 public classes, but it also has a lot of internal classes. And these are ones that you're not supposed to use to develop your applications. Sun and Oracle have always been very public about this, and they've always been very explicit about it and said, they are there, but don't use them. So the most infamous of these is Sun Misc Unsafe. Now, I like Sun Misc Unsafe. The clue is in the name. Unsafe. Don't use it. So let's have a quick show of hands here. So has anybody here used Sun Misc Unsafe in their code? Okay, I see a few hands raised. Okay, not too many. That's good. Has anybody here used a third-party library or framework like Spring, Log4j, anything like that in there? Yes. So you have used Sun Misc Unsafe. It's just that you don't know it. And this is the problem, is that Sun Misc Unsafe and things like that are very useful. They're very powerful in terms of what you can do from a performance perspective and some of the things that you can do that you can't do in normal Java. So fencing and applying atomic operations without having to create an atomic class and so on. So this is all very good. But the problem is that because so many people have used Sun Misc Unsafe in these frameworks that other people use, it wasn't going to be practical to simply turn off access to the internal APIs and break everybody's code. So they said, right, we'll let you do that with some command line options. And that's what you're going to need to know about when you migrate your applications. How do you migrate an application to the module system? Well, the easy thing to do is to simply say to yourself, let's ignore the module system. So all the modules are there and they work quite happily, but let's just ignore the module system. So we leave everything that we've done in terms of using the class path alone. Everything that's on the class path, it becomes part of what's called the unnamed module, because we have to have some way of integrating with the module system. And so the sort of migration path is that anything on the class path becomes part of one big module, which is the unnamed module has no name. To make that work, all of the public packages that you have in your classes on your class path get exported by default. So there's no control that you have over that. And the unnamed module depends on all modules which are on the module path. So the dependencies between the two work quite nicely. There's no issues with that. So you can leave everything on the class path and just make your application work that way. For simple, straightforward applications, you will find no problems with saying, okay, just take the same startup script, run it, and your application works as you want it to. If you then want to sort of migrate to the module system, you can do it in 2 steps. First thing you can do is you can say, okay, I've got some jar files on my class path. What I'm going to do is I'm going to take them off the class path, and I'm just going to put them onto the module path. At that point, they become what are called automatic modules. Because they don't include the necessary module information in the form of the module info.class file, the module system will look at them and say, aha, this is a sort of module, but it's not really a module. So what I will do is I will name that module based on the name of the jar file. And again, any package that is exported from, or any package that is in that module, that jar file, gets exported to the other modules on the module path. And from the point of view of dependencies, that module, because it hasn't declared anything, will have a dependency on all other modules on the module path. So everything gets resolved in the way that you want it to. If we look at that in form of a picture, basically we leave everything on the class path to start with. We have the jar files on our module path, which will be the JDK modules. What we can then do is we can say, okay, that works. Let's migrate one of those jars onto the module path and make it become an automatic module. So its name is derived from the name of the jar. The exports are all the public packages, and it depends on all the other jars on our module path. And then if we want to go one step further, we can actually rebuild our jar with the module info.class file, which can express exactly which packages we want to export, who we want to export them to, and which modules we want to have a dependency on in order for our code to work. So it becomes a proper module in the sense of the module system. So we can do it in 3 different steps. Now, from the point of view of compatibility, the idea originally was to turn off access to internal APIs. And as I said, to avoid real problems with backwards compatibility, Oracle said, okay, we won't do that by default to start with. So they introduced this wonderfully named big kill switch option, and it's illegal access. So illegal access is something that you can specify on the command line, and it has 4 different parameters that you can provide with it. By default, the version that when you run the JDK at the moment, it will use permit. What permit does is it says, if you want to gain access to the internal APIs, then you get access to them. So there's no problem with your code referencing some misc-unsafe or something like that. What it will also do is when you reference one of these internal APIs, it will produce a warning message the first time that you use it. If you want to get more information about how your application is using these internal APIs, then you can change the setting on illegal access and say, give me some warnings. At that point, you get a warning for every time you use a particular internal API. If you need even more information, then you can set it to debug. And debug will print out a warning every time you use an internal API, and it will give you a stack trace so that you can see in your code where you got to in terms of using that particular API. And then the last option, which is the one which at some point should become the default, is deny. And that will turn off access to all encapsulated APIs. No idea when that's going to become the default. Probably not anytime soon would be my guess, because of the number of people who have used internal APIs and still need access to them. If you don't want to use the sort of blanket approach where you just turn on access to all the internal APIs, then there is a way of doing it in a more fine-grained way as well. So there are 2 other options you can use on the command line. First is add exports. And in that case, what you can do is you can specify that you want to add an internal API from a particular module. So in this case, it's going to be Java Management Module. And the package that we want to gain access to is ComSun JMX Remote Internal. And we only want MyTest module to have access to that. So long as we specify that, then MyTest can gain access to it. If you want everybody to have access to something, then you can do Java Management as the module, Sun Management as the package, and then say all unnamed. And that means that anything on the class path can gain access to that particular internal API. That's for being able to import and reference classes in the usual way. If you need reflective access to any of these APIs, then you can do it with the other option, which is add opens. And that works in exactly the same way. So you specify the module, java.base, and you specify the package, in this case, Java util, and we can allow all of the internal parts of that to be accessible through reflective access to everything on the class path. If you want to do that kind of thing, but you don't want to force people to have to change the command line that they use to run the application. So let's say you've created a library and you need some access to internal APIs, then rather than saying when you deploy with your particular library, you need to change the startup script and add the relevant command line options, you can actually put it into the jar file manifest as well. So you can do something like add exports in the manifest and say Java base Sun security provider, and that will grant access to everything within that jar file to the internal APIs of that particular package. There is a nice little tool called JDeps, and JDeps will help you track down where you have dependencies on different modules in the system and different packages and so on. In the past, because JDeps was introduced in JDK 9, it was a bit rough around the edges, and it had some different things that it did which weren't really ideal. But certainly from JDK 11, they've improved it a lot, and so you get a nicer output. This is just a simple example here where I ran it on an application that I created, or a jar file I'd created. It allows you to do static analysis on jar files. You can do it on class files as well if you want. And in this case, I've said, okay, list out all of the information about this particular thing. And it says, okay, so interestingly, it's picked up on a particular JDK that had an internal API removed related to iOS. Then it tells me that I've used Java Base, very logically, Java Data Transfer. Some strange reason it breaks out certain things in desktop. I don't know why it does that. Then we've got Java logging, scripting, SQL and XML, and some of the JDK modules as well. So we've got JavaScript objects there, unsupported. So somewhere, something in my code is using some misc unsafe or something like that. Probably because it's unsupported desktop as well, it'll be something in the JavaFX side of things, and XML DOM. But it gives you the list of all the things that you've got in terms of modules. And then you can also use other options to drill down deeper and see where you've got dependencies on specific packages and so on. Missing modules. So this was something that changed in JDK 9. And again, so Mark said, if your code only uses standard Java SE APIs, it will most likely work. This is one of the things that might catch you out, because in JDK 9, one of the meta modules, which is called java.se.ee, although it is part of JDK 9 and part of JDK 10, it's not included by default for either compilation or runtime. So if you use any of the packages which in the modules of that aggregator module, I should say, your code will not compile. And if you take the code that's been compiled on JDK and you try and run it on 9 or 10, it won't run because it won't be able to resolve the packages and the classes that you need from those modules. In terms of what's affected by this, there are 6 modules. First of those is Corba. So anybody here using Corba? Oh, okay, a couple of people, right? So that's going to be an issue for moving your application, because Corba, because it is now, quite old and sadly not many people use it, it's something which they've decided to remove. Java Transaction is related to Corba, so it's just a couple of odd classes or packages they put in a different module. Java Activation is the Beans activation framework. Then we've got XML binding, so JAX-B. Anybody using JAX-B? Okay, few people. And the one that seems to catch out a lot of people is the JAX-WS, which is the Java XML Web Services way of doing things. But it's the old SOAP-style messaging rather than the RESTful approach that we tend to use nowadays. So anybody using JAX-WS? Yes, I was going to say, yeah. So this is the thing which, you have to look at this and say, okay, how do I get around this? Now, most of these is fairly straightforward. So for 9 and 10, you simply have to add something on the command line. So in terms of using those missing modules, for 9 and 10, it's fairly easy. You can simply say add modules and the module that you need, because they are still there. It gets different in JDK 11. Alternatively, all of the modules except Corba have standalone versions. You can get them from Maven Central. The relevant JSR has a reference implementation, so you can get a version from there, and you can deploy them either on the upgrade module path, or you can stick them straight on the class path. So there are ways of getting around that on 9 and 10. Small incompatibilities for JDK 9. Right, so one of these is project coin or milling project coin. In JDK 9, the Java developers decided that a single underscore was now going to be a keyword in Java. So again, let's hands up anybody who's used a single underscore as a variable name. Couple of people. Okay, interesting. Now, the reason they did this was because they have plans for the single underscore in the future. And what they want to do is they want to be able to use a single underscore in Lambda expressions so that you can effectively hide a variable, a parameter of the Lambda expression if it's not used in the body. So you can use an underscore, single underscore, as the variable name for the parameter of a Lambda expression. And then if it's not used, it sort of makes it easier to see what's going on. I did check, though, for those of you who have used a single underscore as a variable name, and it turns out that you can still use 2 or more underscores as a variable name, and it's quite valid. So a simple search and replace for your single underscore into a double underscore will solve the problem for you. I don't know why you'd want to do that, but anyway. Moving on. Right, so they finally decided that, having introduced deprecation 20-something years ago, that they were finally going to remove some methods and classes and things from the standard APIs. So they didn't exactly go overboard in JDK 9. They removed 6 methods. That was it, 6 methods. That's all they did. So there's 3 classes, Java util, jar pack200 and unpack200, and then Java util logging log manager. And all 3 of these classes have 2 methods in them, add property change listener and remove property change listener. And they remove those. So they are gone. So if you've used those, which is very unlikely, then you will need to change your code. Now, of course, you look at that and you go, well, hang on, what did those 6 methods do that was so bad that meant they were the ones that got removed first? And it turns out that when they wanted to divide up the rt.jar file into modules, they discovered that there were a lot of rather odd relationships between different bits of code. And because it's grown organically, obviously, when somebody introduced a new API, they looked at all the possible things that were available in there already, and they just used whatever they wanted. And sometimes they had these odd relationships, which meant that it was very difficult to break up the relationship between these modules, and you end up with all modules depending on all other modules, and it just kind of gets messy. So by removing these 6 methods, they could actually simplify the module system greatly. So that was why they did that. There was also a class which got removed. It wasn't part of the standard classes. This is part of the Java Authentication and Authorization Service. So if you have used the com/sun security auth callback and dialog callback handler, then you're out of luck because that has gone in JDK 9. However, it was deprecated in JDK 7, so if you have been using it, you would have been seeing warning messages when you compiled your code since then. Again, to help you with this sort of thing, there is a tool, and this tool is called JDepreScan. The idea is, again, you can statically analyze either class files or jar files and look at wherever you've used API elements which have been deprecated, and you get a report so that you can then go back and trace it in your code and figure out, okay, do I need to change my code? Do I need to remove something? Whatever. So just as a simple example here, I wrote a piece of code which used several deprecated things. And when I ran JDepreScan on it, you'll see that in this case, it was using a type, the RMI security manager, which had been deprecated. There was a method, a couple of methods that were being used, and it gave me information about those. So I could actually go back and change the code if I wanted to. The structure of the JDK and the JRE. Now, this has changed, and you might think, well, why am I telling you about this? And the answer is that if you have written code which relies on specific files being in a specific place in the JDK, then that might cause your application some problems. So typically, this would be if you've written some sort of tool that works with the JDK. So most people won't see this as a problem. In the past, before JDK 9, we had a slightly odd structure to the JDK. So the JDK had a bin directory which contained the Java runtime and had some other tools and things in there. It then had a lib directory which had tools.jar, and then there was a separate subdirectory called JRE. JRE had a bin directory which had an executable for Java in it. It had Java C and things like that. And then the lib had rt.jar in it. And the idea was that to try and make the Java runtime smaller, the JRE was a subset of the JDK. But it was sort of a little bit messy because you had this idea of 2 bin directories, 2 copies of Java, and it just wasn't quite what we really wanted. So in JDK 9 and later, that's been flattened out. And it's also been tidied up. So now we have a bin directory, which has Java and Java C and so on. We have a conf directory, which is where any files which might need to be changed for the configuration of the JDK have been placed. In the past, they were sort of spread around and it wasn't obvious which ones were which. So now they're all in the conf directory. Lib is where you get the native libraries for the particular platform you're running on, and jmods is where you will find the modules for the JDK itself. The important thing here is that there's no more JRE directory. So there's no more JRE at all. There's no more tools.jar, no more rt.jar. I do see a lot of people saying, well, where do I find the JRE for JDK 9 or JDK 10? And the answer is it doesn't exist. The whole goal of JDK 9 and later is that if you want to reduce the size of the JDK, you use JLink and you build a runtime which is tailored to your specific application. The version string format. Now, again, This is a very sort of obscure thing that might affect a very small number of people. But if you are parsing the version string of the JDK in your application, then you might need to look at the code that actually uses that and make some changes to it. Versioning in Java has been, it's been quite a journey, shall we say. And I did a bit of research on this, and it turns out that we've had almost as many version string formats as we've had versions of Java. They seem to literally change every time we have a new version of Java. And what that's resulted in is some very strange things. So, for example, if you were to go and download a version of Java SE, let's say you go Java SE 8 update 131. Okay, great. The problem is that if you then go and do Java minus version, it'll actually come back with 1.8.0_131, which is, it's like, well, where's the 1 point come from? This is Java SE 8, not Java SE 1.8. But this is because engineering bumped into marketing, and so there was some problems with the whole version string thing. As of JDK 9, that's the other thing, is sometimes it's difficult to know which version or which update has more patches in it. So, for example, would update 55 have more patches in it, or update 60? And the answer is update 55 has more patches in it than update 60 for some bizarre reason. So now we have the new improved ultimate version string format for Java. This is good because now we have the feature release. So that's going to be the big number. So that's like 9, 10, 11, 12. Very logical. Good. Okay, got that. Then we have interim. Okay, interim is always going to be 0. Right. If it's always going to be 0, why do we need it? But the answer is that that's for future proofing. So maybe at some point in the future, there will be a 27.1. something version of Java. Then we have update. Again, this is logical now because it goes up incrementally. In JDK 9, even, there was this issue because if you looked at the updates to JDK 9, it was JDK 9, JDK 9.0.1. What do you think the next update was? You would think it'd be JDK 9.0.2, but you'd be wrong. It was 9.0.4. That was because they had to keep a couple of numbers in between in case they had to do an emergency update. So now they've got patch, which means that they can put another number on the end if they need to for emergency update. So finally, hopefully, this is the last time they're ever going to change the version string format. Non-programmatic issues for JDK 9. Java Network Launch Protocol is related to Java Web Start, and it uses a markup language to define how your Web Start application works. In the past, they've been a bit lax about how they parsed the files, and they would let you get away with certain things that weren't strictly the syntax of the file. Now it employs strict syntax checking, and so a file that could have parsed in JDK 8 may not parse in JDK 9 or JDK 10. Another thing that you will see is that the extension mechanism, the endorsed standards override mechanisms, have been removed. This is again related to the module system because they've changed the class loaders, which are required when you start up your application. And so both extension and endorsed standards override mechanisms have gone away. But the impact of that is that there's a couple of directories in Java Home lib. One is ext, the other is endorsed. Those directories have disappeared. And if you think to yourself, oh, hang on, I need the ext directory because I've done some JNI code and I want to put a library in there. If you create it, it will stop your JVM from running. So you'll get a message, as you can see down here, which says, no, I'm not going to create the Java virtual machine because you have put an ext directory in the JDK. So no, it's not going to start. So just be careful about that. GC options. So lots of GC options got deprecated and then they got removed in JDK 9. Mostly around things like incremental concurrent mark sweep. There are a few combinations of things that got removed, like the parallel new and serial old collectors working together, which is a very strange idea of doing that. But essentially, all these things are now no longer supported. But again, they've been deprecated since JDK 8, so you would have been seeing some warning messages about those. Logging. Right, so logging in the JDK switched to using a unified logging system across all the different subsystems. In the past, each subsystem had its own way of doing it. Now it uses a single way of logging messages, I'm not sure whether it's log4j or the logging internal. Anyway, and the impact of that is that the GC logging now uses the unified logging system. And again, the reason I'm telling you this is because if you have written tools which parse GC log files, and I know lots of people do things like that, then you might find that the format of the messages has changed slightly, and then you're going to have to change the code for your application to make it parse them correctly. Right, lots of flags have been removed in JDK 9. I'm not going to go through all of these, but essentially there's a whole list here that you can look at when you look at the slides later on, and these will simply be ignored by the JVM, which is fine. So things like bound threads have gone away, lazy boot class load, all that sort of stuff has gone away. But they're ignored by the JVM, so it's not a big issue. Then a lot of flags have changed, and these are the ones where you might be a little bit more it might be more obvious to you, because things like print GC, which is one that I know a lot of people use, print GC details, that now uses -xlog::gc or -xlog::gc star. And then there's a whole lot of changes to different things there. Again, with most of these, it's not too much of an issue, because what's going to happen is if you use the old flag, you don't change your startup script, then in most cases, you'll see something like this where it says it's deprecated, and the JVM will make the appropriate change for you in terms of it starting up. Or it'll tell you that there's a different one that you could use. So the problem ones, there are 50 command line flags that were removed from JDK 8 that will actually stop your JVM from starting up. So this is where you are going to have to change the startup script. And the sort of things that are ones that catch you out are things like print heap at GC, which again, this is a common thing that many people use. Trace dynamic GC threads and stuff like that. So again, I'm not going to go through the whole list of 50 of them, but there are a number of them that do that. Right, JDK 10. Okay, local variable type inference was the big thing that got introduced in JDK 10. var is now a reserved type. Fortunately, it's not a reserved word. What does that mean? Well, it means that we can still use var as a variable name. So we can say var equals new value-added reseller. That's quite legitimate. But what you can't do in JDK 10 that you could have done in JDK 9, but nobody here would have done, is create a class called var with a lowercase v, because that would be too much like .NET. So we don't do that. And so what we do is we would use uppercase v, and we can still call it public class var with an uppercase v, but you can't create lowercase v class. Just a slight change. Various deprecated things got removed in JDK 10, so this was again a continuation of the cleaning up. And again, a lot of these are things that aren't going to catch out many people. So for example, the JDK security auth module, within that, there is the com/sun security auth package and policy file, and a couple of Solaris related things and X500 related things have all been removed. And again, the auth module, a couple of classes related to Solaris got removed. So if you're not using Solaris, most of those are not going to be a problem. The security manager had a number of things removed. So this has actually had a field removed called incheck. And then there are 7 methods that got removed: class depth, class loader depth, current class loader, and so on. Again, these are things that haven't been used for a long time, and so it's very unlikely that you're using them in your code, but be aware that there might be some dusty code from many, many years ago that has actually used these things, and you might need to make some changes to your application. Java Lang runtime lost a couple of methods, but these are obsolete internationalization methods for get localized input stream or output stream. A couple of miscellaneous things. So in JDK 10, they removed the Java H tool. So this is the one that you would have used for JNI in order to create header files. Now, rather than doing Java H, you do Java C -H. It does the same thing. And the policy tool got removed from JDK 10 as well. More about command line flags. So -D32 and -D64, no longer valid. Oracle have moved away from the idea of having 32 and 64-bit JVMs. So there's no requirement to be able to specify one or the other. It's always 64-bit from Oracle, or you can get a 32-bit version from other people, but you don't need to specify the thing on the command line. Then there were these 5 -X options that got removed. And I looked some of these up, and -X SQ no pause. Got no idea what it does. Couldn't find out what it does. So I'm guessing not many people actually use it. Like I said, bound threads and stack size might be some things that cause a problem. Again, these will stop your JVM from starting up, so they could be a bit of an issue there. JDK 11, moving on. What did we get? What changed in JDK 11 that could catch us out? Well, the big thing here is that now Oracle made a decision. This sort of goes back to JDK 9. They made a decision about eliminating differences between the Oracle JDK and what's in the Open JDK source code repository. Oracle, since JDK 9, have been doing two binary distributions. So there is the Oracle JDK, the one that you download from java.oracle.com, and then there's this other one that they do, which is the Oracle OpenJDK JDK. I have to say it like that because Mark Reinhold tells me that OpenJDK is an adjective, not a noun. So it's the Oracle OpenJDK JDK. And that's under GPL v2 with Classpath exception license. So it's less restrictive than the Oracle license. But the idea now with JDK 11 is there are no functional differences between those two builds. What does that mean? That's quite significant. Oracle removed three big features from the Oracle JDK, and these are things that weren't in the Open JDK source code. First, those is JavaFX. That's not too much of an issue. Anybody here using JavaFX? Don't see many. Do I see any hands? Okay. Well, even if you are using JavaFX, it's not too much of an issue because that's been open sourced. There is a project under the Open JDK bigger sort of area for that. There's a company called Gluon and Azul and myself, the company I work for, we provide binaries of that, so you can still get that. Browser plugin. Anybody using applets? No, good. That's what I like to see. So nobody's using applets, so that's not going to be a problem. Then Java Web Start. Anybody using Java Web Start? Okay, yes, one or two people there. This is a bit of a problem because I know that a number of customers I've come across have been using Java Web Start, and there is no direct replacement for that. There's no easy way to simply say, okay, we'll drop this in. There are a couple of projects that do similar things. So there's the ICT Web project from Red Hat, which is close to being a drop-in replacement, but it still needs some testing and reconfiguration for your application to make it work. There's things like Get Down, there's things like Install4J that other people have used as a replacement to do that. But it is something that if you are using Java Web Start, you need to think carefully about how you're going to migrate to JDK 11 or later. Lots of tools got removed from JDK 11 as a result of the removal of the browser plugin and Corba and various things like that. So Applet Viewer went away, all the Corba tools went away. Monitoring tools, things like Java Mission Control, that's now a separate download. Oracle open sourced it, so it is available, you can use it, but it's a separate download. Things related to Java Web Services, JAX-WS, so SchemaGen and all those things, they got removed because they removed all of those modules. And the deployment tools also went away. So, yes, the aggregator module, Java SE.EE, that got removed completely. So now you can't simply say, right, just re-enable the module because it's still there. It got removed completely, and so you have to download a module from somewhere else or the jar file, put it on your class path, and resolve it that way. So there is some work to do in that sense. A few other things that got removed in terms of APIs, so things like the Java x.security.auth.policy, a couple of security manager related things. Finalizers are something which they are trying to sort of find a way of getting away from. So the run finalizers on exit method has gone away from both the runtime and the system class. Thread.destroy has finally been removed, and thread.stop, but not the one that takes no argument. So they left that one in there, but they removed the one which takes a throwable as a parameter. Don't know why they did that, but they did. A few miscellaneous things that disappeared from JDK 11. Again, this was part of the sort of convergence that Oracle wanted to do between eliminating differences between the Oracle JDK and Open JDK. So they did provide SNMP monitoring support. So there's a module that disappeared for that, jdk.snmp, and the relevant MIB file also got taken away. A couple of things on the desktop. The T2K font rasterizer was removed, and they decided to remove the cross-platform fonts that used to be part of the JDK. So there are a set of Lucida fonts that you could use if you wanted the same look and feel for your fonts across all different platforms. With Open JDK now, they don't provide those fonts, so everything defaults to whatever fonts are installed on the machine that you're running on. Certainly with Azul, we've actually sort of gone back and we now provide the Lucida fonts if people need them with our Zulu builds. And then there's some stuff around security certificates, which is again sort of just cleaning up things and removing some of the ones that are no longer required from the trust store. Just briefly talk about JDK 12 because that's the current release. Not many things there because there weren't actually a lot of changes from the point of view of JDK 12 at all. So the ComSun AWT security warning has been removed. That's an internal API. It's not even used in the JDK, so that's not a problem. Finalizing methods. So I said that they're trying to get away from that. So file input stream, file output stream, zip file, inflator, deflator, all of those finalized methods have been removed, so they don't exist anymore. And again, updates to the CA certs file, and the fact that because we've moved to a newer version of the JDK, they've dropped support for JDK 6 or 1.6 as an option for the Java C compiler. So you can no longer generate JDK 6 code from JDK 12, which kind of seems logical, really. Command line flags. Yeah. So again, I just sort of thought I'd go through this because it's interesting to see how many they removed and added. So in JDK 9, they removed 82 -XX flags, which kind of makes you realize that there must be an awful lot of them if they can remove 82 and nobody really noticed. But they added another 72 to make up for it. JDK 10 was a little bit less extreme. They removed 18, added 20. JDK 11 removed 16, added 34. And then in JDK 12, they added 66 more. 58 of those were for Shenandoah, so that was one of the big features. There's a nice website here, chriswhocodes.com, and he has a page that gets automatically generated and shows you all the differences between the different versions, which things have been removed, which things have been added, and a minimal amount of information about what those flags actually do. So conclusions-wise, migrating to JDK 11 or 12, simple applications will run pretty much without any changes. Leave everything on the class path and simple applications will just run. You might need to make some changes to the JVM flags because of all the toing and froing, things being removed, things being changed, and so on. Encapsulation is if you're using third-party libraries, third-party frameworks, and those libraries make use of things like Sunmisc Unsafe, then you might have to do some work there. And then there's all these very small edge cases, but I think most people will not be caught out by the majority of those. Maybe WebStart is probably the one that I've noticed most people are going to be affected by. Since I work for Azul, I'll just briefly mention Zulu Community Edition, because this is our free build of the Open JDK. Notice the keyword there, free. You don't have to pay for it. And what we do is we build what's in the Open JDK. We then run the TCK on it, so you know that it passes all the tests associated with Java SE. We have a wide range of distributions available. We have 7, 8, 9, 10, 11, and 12. I'm not sure if we've actually got the 13 early access up yet. I don't think we have yet, but we will have shortly. We also have wide platform support. So we have the normal 64-bit versions of Windows, Linux, and Mac, but we also have, for people who want older versions, run it on an older version of the operating system, we've got Intel 32-bit Windows and Linux, and we have ARM 32 and 64 if you want to run it on something like a Raspberry Pi or a 64-bit ARM running a data center. And because we are really nice people, we also have commercial support available at a very reasonable price. See me about that later. And with that, thank you very much.
So I'm asking you to go and have a last lecture in ISAN, the big. There will be in the end the lottery, and it will be finishing. Thank you.